Welcome to Building Sustainability Podcast with me, your host, Jeffrey Hart, aka Jeffrey the Natural Builder. Every fortnight, join me as I talk to designers, builders, makers, dreamers and doers, exploring the wide world of sustainability in the built environment by talking to wonderful people who are doing excellent things. Hello and welcome to episode 77. I have got 2 episodes for you that I recorded at Futurebuild 2022. That was back at the beginning of March in London XL. I was there as part of the ACAN, the Architects Climate Action Network area, and I was very pleased to be discussing straw as insulation and earth floors with really anybody who would listen. Really fantastic to connect with so many wonderful members of the public, people I'd met before, listeners to this podcast. Got to hang out with a lovely bunch of natural builders and geeked out about all sorts of things. And of course, all of the ACAN team who came together to build a really great area. It really was the highlight of the show for many people. So thank you to everyone that I got to hang out with. It was totally worth catching COVID for. So I was able to find a bit of time to wander around the XL Centre and find a few interesting people to talk to. There is quite a bit of background noise and somehow my voice is very low in the mix. That was me not being very used to field recordings. This might not be the best thing to listen to if you are in a van or sort of noisy. I don't know if you're going to cut through the background noise. I've done my very best to remove it. And, maybe this doesn't work so well and I won't do it again. Do let me know in the Building Sustainability Community Facebook group. A useful forum for feedback and letting me know that sort of stuff. Also, it's a trade show, so you get that sort of trade show style of talking. Yeah, it's not the normal relaxed drinking tea building sustainability podcast type episode. Okay, so first up we have Vince House from Erico talking about demand controlled ventilation. Interesting stuff. Have a listen.
This ventilation system modulates airflow according to the demands of the property. And that we know that would change room by room. So there'll be a varying demand for ventilation, depending on what's going on. If people are sleeping at night, that's the room that needs more ventilation. If they're cooking in the kitchen, that would be the area that needs the most at that time. So what we've got here is a system that can monitor that and change what it needs to do to make sure that we're always in that sweet spot of humidity. So
it's humidity or
it's humidity driven. So there's an optimum zone between sort of 40 and 60% in our homes, which is what we want to achieve. We're looking at trying to get in the middle of that at 50%, but obviously there'll be a plus and minus depending on what the activities are. So the way that it measures it is having a sensor in each room, and very straightforward sensor. When you talk about sensors, people normally think about some electronic device that's going to pick up CO2 or whatever. But these are basically nylon.
Oh, wow. 8
nylon strips. And what happens to nylon as a material is when it becomes moist, it grows in length.
Right.
And when it dries, it shrinks. So what we can do is then amplify that motion of, expanding and contracting and modulate airflow. And that's either exhausting from those wet rooms, or to bring the air in, again, it will modulate the airflow into the house. Whatever you're pulling out needs to come back in.
Yeah.
So then by having that very simple but effective sensor, which we've been doing those for 38 years, we give a 30-year guarantee because there's not a lot to go wrong, frankly. So it's a really good life expectancy of the units. But they're really accurate. And we still believe that in terms of measuring indoor air quality, moisture still seems to be the best and most, I suppose, the easiest thing to detect to actually monitor what the rest of the indoor air quality is. Because if you're measuring moisture, you by default you're dealing with CO2, you're dealing with VOCs, you're getting rid of all of those nasties as well. So I suppose where it is a little bit different is in its operation, you're modulating airflow, and you'll have the wet rooms normally connected back to a centralised system. Now, depending on the building, if it's retrofit, it's not always possible to have lots of ducting going through a property.
Yeah.
So in those scenarios, we might have more than one fan unit localised to that wet room or those wet rooms.
The type like we're looking at here, so like a bathroom extractor.
Well, you'd probably have a grill like this, which is like a regular bathroom extract, but then that would be ducted back to a larger fan unit. Right. And we believe in the principle of capacity of our buildings. So it's no point having a fixed rate ventilation system that has a ceiling figure, right, or a minimum figure as well. What this can actually do is go way above building regulations if the demand is there. Because we're assuming lots of things on building regulations. We're assuming capacity, occupancy, and that sometimes 80% of the time is correct.
Yeah,
but it can fall over very quickly. Yeah, and that's typically what we've found in social housing, particularly in areas where there's over occupancy because it's quite expensive to live in those areas. And that's when those issues of excess moisture come in. You get the condensation, you get the mould because the system has a ceiling level on it. So normally our design might be up to twice as much as what building regs would require, but because we've got those sensors that are actually modulating according to the demands, it's only ever going to ventilate what it needs to. And that brings you on to sort of that efficiency part of it. Because ventilation clearly is all about indoor air quality. That's the primary goal. We manage that very well. But secondary to that, you're always looking at the energy efficiency. Now, we found and have known that MVHR is a very good system, and it delivers good indoor air quality and it recovers that energy. Yeah. Without very sophisticated controls, the thing that it doesn't necessarily do is do that intelligently. You tend to ventilate the whole house regardless of occupants in different areas. So for that process, you can actually end up using quite a lot of primary energy to extract out of those wet rooms and to supply back in.
Right, yeah.
So to get the energy back, the heating element back, you actually have to use quite a lot of energy to make that happen. And that's one of the things I really like about this system, because you're only ever ventilating according to the needs. You're never underventilating and you're never overventilating.
Yeah.
So there was a report that came out by Ghent University. I don't know if I pronounced that right, but they're in Belgium. They looked at 274 passive houses, and half of those houses had MVHR, and the other half had a demand control ventilation system.
Okay.
Exhaust only, extract only, no heat recovery. They tested those houses, monitored them for 12 months. And what they really wanted to do was look at three criteria. What was the indoor air quality like in each one? That's the first thing.
Yep.
How much less heating cost was there for the heat recovery system? And what was the energy to run those? So the indoor air quality was nothing. It was a draw.
Right.
Well, one didn't win over the other. It was that was just, you couldn't choose between the systems. The heat recovery, not unsurprisingly, was more efficient. I believe it was around 6% energy saving on the heating, so that's good.
Yep.
So that was a win for MVHR. When they looked at the primary energy, it was 5 times the usage.
So, sorry.
5 times the usage for MVHR
and
to
primary
recover.
energy means
What it actually costs, how much power is that unit consuming? So that in itself is a commodity that's really important.
it's your energy.
Yeah, it's your energy. It's your electricity to run that unit. So you had to use 5 times the amount of energy to get quite a small amount of heat back.
Yeah.
And actually, when you added those two elements together, you weren't better off. It was a net loss compared to the demand control.
So command control, just ventilating air straight out.
Without heat recovery, was actually more efficient in that study, which is an absolutely mind-blowing thing. And all the passive house nuts would just they'd absolutely crucify me at the moment. But it's there. It's a study. It's a 149-page document.
Right.
And actually, what I quite liked about that study, it just shows that it's not the only way. And I think primary energy, and also when you start looking at the other elements like the embodied carbons, I mean, how much product you've actually got to put in to systems, that is becoming a much bigger deciding factor now. But the one thing that study also showed was, what does it cost you? They did a projection over 15 years, and they said, right, we're looking at the capital expenditure, how much for that equipment, how much to run it, and how much to maintain it. And the headline figure on that was that it would cost you €350 a year more to run MVHR.
Wow.
With no seeming benefit of indoor air quality, which is the whole reason that you're putting that system in there in the first place. So a really interesting report, frankly.
That is fascinating, yeah. And that's obviously, so you said that was passive houses?
They were passive houses. So
is there any such sort of report on regular houses?
So what we found, we did some like for likes in Tipperary.
Okay.
And actually we were looking at heat metering on those properties, and they weren't passive house standard. They were just fairly regular, probably what most people are living in today. The differences we found between those was about £1 difference in consumption per month. So actually
£2 now.
Probably £2 now. Yeah, but then again, when you start looking at the capital costs, when you start looking at maintenance, filters need replacing, and that could quickly offset any savings that you might get on the energy. So it's a really interesting thing. And look, we've done quite a lot of passive houses or net zero energy buildings in London, NZEB, sorry, in Ireland. I don't know what I'm saying, London. In Ireland, there's a lot of NZEB properties, and that primary energy element is quite key. If you're harvesting or producing your own electricity, you don't want that all feeding products and systems that are just constantly chugging away without any intelligence behind what they're doing.
Yeah.
So it's quite an interesting world when you start looking at the different technologies available.
What I really like about yours is that it's intelligent, but it's really simple. Like, it's basic.
Yeah.
That's really. That sort of seems like a dream. Dream solution, really.
And listen, the passive element is quite nice. The inlets that we use. There's no wiring, no batteries, and I was chatting to a chap a couple of days ago who has got a property in Wales and just wanted virtually no electricity. So we use we're going to design for him a passive stack system. And because we have humidity control on our grills, he will have a completely energy-free ventilation system.
Fantastic.
And it will work really well.
Yeah.
Like, no question of doubt, it will work really well. We'll design it for him. And he was really excited about the fact that he could have something that was completely passive and still offer. I mean, we need Mother Nature to help a little bit with the passive systems. You can't always rely.
So when you're saying passive, you mean like no fan? Is that
no fan, no electronic fan. So just by using the chimney effects, the draw of temperature difference or wind speed going over what would be the top of the stack for the ventilation. But cleverly, because we have these nylon sensors that can open and close according to the humidity, you've got a control element.
Yeah.
So it's not like just having holes all over the property. You've got that control to help minimize drafts, because that's another big thing.
Yeah.
You know, although in Europe we refer to drafts as ventilation. In in the UK it's drafty. But look, I totally get that, because holes in walls without any control is not necessarily a great idea.
Yeah, no, definitely not.
Yeah.
And I guess, I mean, my hole in a wall seems to be, cold air condensation issues, hot air meeting cold air.
Yeah, I think the thing is it all depends on, I suppose, the air tightness of the property and when you have a negative pressure system, so you're drawing air out of the property, you're taking that stale air out, you have to reintroduce it. So it's all about where you're bringing it in from. And obviously, if you've got a system that opens and shuts the aperture according to the demands, you're going to be bringing it in very defined areas.
Yeah.
And normally that flow of air is enough to stop any condensation. If there is condensation, it might be a cold bridging issue, or there might be some other element. But typically, a hole in the wall would produce that. Put a decent controlled ventilation system behind it, it doesn't become an issue. It becomes part of the system, actually. Yeah.
Right.
Yeah.
That's fantastic. I'm sorry, can you say your name and the company?
Oh, yeah. So I'm Vince House. I work with Erico. I'm proud to work with Erico. And I'm happy to talk ventilation. It's what I do.
Brilliant.
And here is a little bit more from Vince.
One of the things that I see a lot in the industry is you can make the best products going, really efficient products, but actually, unless they get commissioned correctly and installed correctly, they will fall over.
Yeah.
And this is a big issue that we have in the industry, where there doesn't seem to be as much skill. And I speak to a lot of electricians and talk to them about ventilation and duct runs, and they say, well, look, I'm just an electrician. This is way over what I know. So there's a real education. And one of the things we like to do, and something that has made us get all that repeat business, is following the process from end to end. So it's really important to have a design, something that's going to work. You're taking into account everything about that building and what usage it might have, and obviously you want to make sure that you adhere to building regs or past 2035. That's part of it, but the real important part is actually making sure that it gets installed. And actually, that's when you've got to work with whoever's been tasked with that job of doing it. And because we certify the systems, we test that they work and they're hitting the design criteria. What you don't want to do is just end up at the very end of a project and test it, because 9 times out of 10 there'll be a problem. So it's much easier for everyone to get involved during the install and making sure that the components or the selection of products is correct on the ducting. It's viable, what routes are being taken to do ducting and things, and and actually when it comes to installing, that we're making sure that we're getting airtight ducting, and making sure it can work. And that if I work well with the contractor or whoever's installing it to begin with at install, give them that knowledge, when I come to certify it, it just becomes a really simple process because we know that everything's been done.
Yeah.
When I've had projects where we've fixed price for them, the product's been bought, and they phone me up and say, right, we're ready for you to commission, my heart just it sinks.
Yeah.
Because you know you're going to go there and it will all be finished, and you're like, right, what size duct in did you use? Because, you know, even though it's written on all our designs, sometimes it doesn't happen. And it can be just embarrassing for everyone and costly as well. Yeah. Particularly when you're saying, look, I've got to stand over this. We've got to get it right, because if we don't get this right, there'll be consequences. So that's something we're proud of doing. We're happy to work with people, and actually those contractors and installers that I have worked with, that is where we get our continued business, because they've had the experience. It's normally been pleasant. They've normally been, even when I think that, you know, this guy's never going to talk to me again, out of the blue, I get a phone call. So, right, I've got another job. Will you come and see me on this one? We'll get it right this time. You know. And that's wonderful, actually. It's great to get that engagement, and you learn so much as well. You know, yes, we're a manufacturer, but when you're actually side by side, you know, shoulder to shoulder with the guys installing it, that's when you learn what you should be specifying, how you overcome those issues.
Yeah, those things that you never considered when you were designing it in real life situations.
Yeah, and particularly for retrofits, really challenging. You know, most properties have not been designed to take M&E equipment. You know, they might be Victorian, they might be older. You know, you've got to find really neat solutions. And where certainly the installers I've worked with, quite often they'll come up with a really neat solution that never crossed my mind. Yeah. And then I gain that knowledge from what they've come up with. And I can then take that to a next project. So, well, yeah, we did this because that worked really well. And I don't know why I never thought of it, but, you know, it's great to work together in those scenarios. And you get those outcomes. That's the thing.
Yeah.
And without that engagement, you can't guarantee that what you're ending up with is going to work. And that's what we like to say, you know, ventilation that works. It's very simple. Yeah. Can be done. Lots of people fail at it for some reason.
Yeah. It does. It feels like quite a new... I mean, you said you've been going 38 years.
38 years, yeah.
It feels like a newer idea, as we've thought about closing up houses more, then the ventilation's become more important.
Yeah.
So it feels like, in the scheme of things, quite a new industry.
Yeah, I think that's absolutely spot on, actually. We've been in the UK for 28 years now, and what we've found in that time is there's never been a greater demand than what we're seeing today. And legislation has helped with that. We got some new information in Part F, new legislation that for the first time we're seeing existing buildings actually, when you're carrying out energy efficiency measures to those, that they should adhere to PAS 2035 or, you know, the latest building regulations, which is something that has never happened before. You know, so the industry is actually understanding and realising, you know what, you can't just start sealing up your homes and not think about the ventilation. And actually, it's been great that the industry's engaging in that way, that we're seeing more from government-based projects, which we're involved in a lot of those decarbonisation schemes.
Yeah.
And there's a lot of learnings there as well. They're trying to find out what's the best methods, and if it's going wrong, why is it going wrong? You know, very much what PAS 2035 is about, you know, decades of getting it wrong to produce a document to say how to do it right. There's never been more focus, but there's still a lot of education. I think one of the real issues that we face as an industry is the value of ventilation. Now, the pandemic has certainly increased the awareness of good ventilation from a perspective of viruses, but what I see more often than not is it's an afterthought, and I might speak to self-builders that have just come along and said, I've been told I need ventilation, you know, and it's sort of something that they hadn't even really factored into their sort of build or their you know, cost of doing that. and that's something that we haven't done particularly well in the UK. If you go somewhere like Sweden, they'll have a moisture risk expert at the start of the project that will follow that project all the way through construction to the handover to the client, where they'll actually say, this is the system that you've got, this is how you interact with it. Yeah, I think they call it the BIGAF method or something. It's in the white paper, Moisture in Buildings, which is a great document produced by BSI.
Right.
So that value of ventilation is the education of why we have it. And I still speak to a lot of building surveyors that we're going into these properties laden with mould and still can't believe it is just poor ventilation that's causing all of these issues. Sometimes that might not be the case. There might be other factors. There might be cold bridging issues with a building. But, the ventilation is a cheap way to, once you know that that's working well, if there's other issues with that property, they'll present themselves in very defined ways. You'll say, right, that is a cold bridging issue right there because it's so specific to that spot. Yeah, exactly. So there's still a long way to go, but I'm encouraged by how the industry is reacting right now.
Yeah.
And certainly we're enjoying lots of engagement on that as well, and education as well. Yeah.
Nice.
Thank you so much, Vince. That was really interesting stuff, and something I didn't really know existed. I didn't manage to find the paper from Ghent University, so if anyone can point me towards it, then I'll add it to the show notes. But definitely the Moisture in Buildings white paper is there in the show notes for you to download now. Next, we are heading to Matt Stevenson from Ecosystems Technologies.
So what we're in here is a demonstrator display unit, which we've manufactured for Suprema Group, our supply chain partner, which showcases all the different natural materials that they can supply to the market within the build systems which we've evolved. So it's really about how to put these fantastic products together into systems that can respond to a whole raft of different applications, whether it's domestic, commercial, schools, just across the board, and just to really try and amplify that this is the way to build in the future.
Yeah. Very aligned in our aims. So we're looking at some pretty chunky bits of wood.
Yeah. So the wood elements, that you can see, we're really excited to be able to present our homegrown mass timber products. So we've been able to finally break that gridlock around bringing homegrown mass timber products to the market. So we've got cross-laminated, glue-laminated and nail-laminated products on show here, plus our glue-laminated timber portal, which is a really efficient structural solution. And what's been exciting is to be able to demonstrate homegrown Scottish timber is absolutely fit for purpose to create engineered products, and that allows us to start really moving that homegrown resource up the value chain, lock carbon in for longer. So really exciting trajectory.
And where at the moment the timber's coming from? They're not homegrown.
Well, it'd be imported engineered timber, which variously from Austria, Germany, France, Spain. There's a plentiful supply of European manufacturers of the product. So yeah.
Right. I mean, I clad my house in cedar, partly, and the battle to get English cedar, not Siberian or Canadian or so yes, I'm fully on board with that.
Yeah, no, good.
How are people sort of taking to this? Like, is the idea of wooden buildings? I know some people are a bit hesitant about wooden buildings.
Yeah, I think we're at an interesting point at the moment because we've finally got that unlocking of awareness of the importance of embodied carbon in our build. So
it's been a long time coming.
It's been it's felt like preaching into the wind for a long time. But no, we've got that moment where that recognition is there. So that creates the really ideal enabling conditions to do the sort of thing that we're doing. in balance with that, of course, we've got a context with concerns over fire, stemming from the Grenfell tragedy, and unfortunately, timbers have been got a lot of the sort of attention as a combustible material, even though it had no bearing. And the bit that I think survived was the fire doors, which were timber. It's unfortunate but it's important that we address these concerns. But it's important to understand that a mass timber solution, is if detailed right, and if we understand the fire strategy, is really important. And we're really fortunate to have a project on the go at the moment with Innovate UK funding, which allows us to get University of Edinburgh to do a whole raft of fire testing on our homegrown product, and that will help inform how we can best use it. And we're approaching it the right way around in that, is seeking to understand that first, so we can actually design the product to perform as well as it possibly can in the presence of fire.
And where might we be using some mass timber?
Well, there's all. It's really suitable for any application, but some of the exciting work that we're doing at the moment is seeing homegrown cross-laminated and glue-laminated timber product going into a zero carbon schools initiative called Gen Zero. So UK government, Department for Education, have just culminated an Innovate UK funded piece of work to look at schools built and delivered in the future being able to be predominantly timber-based, and we've been delighted to demonstrate that could be a UK homegrown mass timber source for that. And so that's a massive application. We're also looking in tandem with that at a retrofit school solution, because it's so important that we're retrofitting as well as building new. So really pleased to be involved with that, and we're also looking at domestic retrofit. And actually, a lot of what's in this stand here is what we're calling our near home solution, which allows us to take a vacant building, whether it's a vacant retail space or an old historic building, and actually create a box within a box solution for that, which is very configurable. It's kit parts configurable. It can be repurposed, reused. So very circular solution for that. So there's a few. There's tons more, but there's a few applications that we're seeing.
Yeah, well, I mean, I'm very pleased to be in here. I was just saying to you that I filled my house with Pava Flex.
Yeah.
So to see that proudly there is great.
No.
And what's the sort of uptake on that, I think?
Well, good. I think. I mean, we're in an exciting position where actually the necessity is to increase the capacity of these natural products being manufactured. Suprema and Pavatex. The materials on allocation at the moment because there's such a healthy demand. Somewhat influenced by policy and policy change towards more use of timber in Europe. So let's see that kicking off to a similar effect in the UK. So it's exciting to see how that can scale and how we can make best use of that natural resource, that biogenic resource. So what these systems seek to do is to use each bit of that natural fibre as effectively as we can, and they're very complementary uses within the system.
Yeah, and the ones you've got on display here.
Yeah.
Am I right in thinking all of those are recycled?
So the Pava Flex would come from virgin material, I believe, but it would be probably a byproduct of the milling process. So it's actually adding value to something that might go to a lower grade solution otherwise. Right. So we're moving it up the value chain, holding it in the carbon cycle for longer. The Pava Textile is a recycled textile product, so that very much is finding a good end use for that recycled product. The Universal is a cellulose, so it's recycled newspaper. So again, very very much a recycled product. Something like the cork product, which we've got within the roof construction, that's virgin material as well. But there's a team here from UCL who are looking at trying to use recovered timber to make CLT. So we had a really good conversation yesterday, and it's just great to see how can we where as well as doing retrofit, where there is any demolition of existing buildings, can we recover that resource and keep it higher up the value chain for longer, and can we incorporate that in a mass timber product? I'd be really interested to see where that conversation could go. So
I just I had a conversation with the guy who manages the estate where I live, and he was saying that they sold a load of sweet chestnut, overgrown sweet chestnut trees, which the timber's bad because it splits naturally. And he said that he sold a load of that for cross-laminated timbers.
Oh, interesting.
You're cutting it up and sticking it all back together. So it's kind of perfect.
Yeah, no, good. Well, we need to find, the majority of this comes from, plantation grown, forestry well-managed forests, and it's that commercial sort of route, but we need to find ways to add to that resource availability by complementing it with, finding ways to use some of the sort of the hardwood species, some of the other, species that more have got less obvious routes to into products and things. So,
just the sustainable forestry.
Yes.
Yeah. How truly sustainable is that? I mean, is it clear felling big strips of?
Well, it's not my area of expertise to properly comment on, but I do believe that forestry management principles are constantly evolving to make sure that there's a balance between the sustainable and the biodiversity and the productive woodland. So, but it's really important that there's a balance in those things, and we need more amenity. Sort of woodland and more engagement for that, but we also need more productive woodland so that we're gaining the resource that we're going to need. It's great if this gets wider adoption. That creates a new headache of where do we get the resource from, and how do we do that in a balanced and sustainable way. It doesn't grow overnight, so we need to be as efficient as we can be, and that we need more. The whole thing of need more timber in buildings, but we've got to be very targeted about it, and the systems we're evolving look to optimise all of the fibre that's in there so that we're only using as much timber as we need to very efficiently. And that, of course, makes it more viable financially as well as more impactful environmentally.
We'll be back after a quick break.
Hey there, I'm Mick from the Mick and Pat Show.
That's right, and I'm Pat.
Looking for a podcast that's like catching up with old friends? Well, you're in luck.
We're here to bring you weekly doses of lifestyle commentary, discuss culture and politics, and top it off with the occasional beer and film reviews.
But it's not just about us, we're a community. Our listeners are our kin, and we let you all have a say in what we discuss.
So saddle up and join the conversation at the Mick and Pat Show. You can check out our website or find us wherever you get your podcasts.
And what sort of, we're stood next to a poster showing the carbon.
Yeah.
What sort of improvements are we getting for
sequestered carbon. So, we're seeing really, really positive benefits. The poster there is very much about the Pava. I think it's about the Pava roof. So it's about comparing that with a more conventional solution. And I think we've got a 60 kilo per square meter difference within that. And that we're not able within those calculations to really look at the whole life cycle, which would give us a further uplift. But if we look, at that at that A1 to A4 sort of phase, then we're seeing that 60 kilo, and that's pushing us into carbon negative with that. So we're excited about the positive impact that can have. I think across the piece, more efficient design. We can have lighter weight foundations. We can have more recoverable sort of materials within the foundation systems as well. So that's the tip of hopefully what's a very big iceberg of benefit. So
nice. And can we geek out about cork?
Yeah, absolutely. It's amazing, and I was so excited to see the image of your unit with the cork as an external material. So that's coming to one of our buildings soon. That's for
brilliant.
Sure. So
yeah. I mean, some people think it's not sustainable.
Right. Okay.
I think there's confusion about how it's processed.
Yeah. No, I'm sure.
Chopping down the trees.
No. Well, I mean, you will probably know far better than than I do about the process. But as I understand it, it can, if done right, and there's always exceptions to that. If done right, it's extremely regenerative and extremely sustainable. And you're not cutting the tree down. Therefore, you're not impacting the ground and the soil conditions and everything else. So it's great that we can find applications for it, because it not only means that the existing woodland can be sustained, especially you imagine how few corks now are made with cork. We need alternative applications, and this is a fantastic application for it. And hopefully that can invigorate more planting and more more woodlands being established. So no, I think that's there's a lot of myths and misconceptions that we have to come across. That's been one of the principal challenges that we've had to overcome with the homegrown mass timber. The perception that the homegrown product isn't suitable, or that we won't get the yields if we dry it, or any number of concerns. The best thing to do is go out, do it, demonstrate it, and then that removes all those misconceptions. And that's this is delivered at commercial scale volumes, so we know the drying process works. We're working with fantastic partners. BSW have got the knowledge to dry down material to the right moisture content. So misconceptions are plague our industry, don't they?
A serious part of my job is. That's my talk here.
Yeah,
on tomorrow.
brilliant.
It's like half of it is what are the misconceptions that you've got?
Fantastic.
And how can I squash them?
Yeah, absolutely. Yeah, no, great. And straws are it's exciting. The first two builds that I ever did were straw bale in a closed panel solution that we came up with. So you haven't used it recently because we're focusing on trying to get the systems and the volume through that, but it's such a great material. So
yeah, brilliant.
I've got our factory in Invergordon. We're about to do our build system, our retrofit build system that we've done for Near Home to do office fit out retrofit solution. We're just about to add some steroids into the mix and end up with an industrial building retrofit system.
Right.
So we will be achieving, I think, something like a 17-metre clear span to do that, and that will allow us to take a 1970s, 80s steel shed that's already exists, but is leaky, is not, we would wish to describe it as a controlled environment, but it's controlled in terms of it keeps most of the rain off. We can convert that into a space that is controllable, that's fit for purpose for manufacturing our homegrown mass timber products with this retrofit solution. That can be in the future disassembled and reassembled somewhere else if need to be, or disassembled and become a new build structure if the external fabric gets to a point where it gets to its natural end of life. Yeah. The internal fit out solution is still got plenty of longevity in it. Yeah. So it's trying to have that full circular and future proofed thoughts in mind.
Do you one of the things I struggle with certainly in a place like this is it strikes me that you're someone who thinks about all. You're trying to find the absolute best.
Yeah, sure.
You won't settle for. We've got this insulation, so that's why we should be using it. So actually, let's search out the very best in all scenarios. Yeah.
So it's an interesting conundrum because you need to be highly collaborative and very uncompromising to do what we're doing well. So those seems an odd thing. Yeah, they're not mutually exclusive. And I suppose what we're driven to deliver is the impact. So there has to be a pragmatism that we need to get these solutions on the ground as soon as possible. So we will typically be trialing something new with every project, and the best time to try the new idea is probably on the project that you're already working on. So that causes us headaches and disruption, but it's the way to advance things. We've got to be impatient. We've got we are in an emergency. We can't do it we can do it in fast increments, but we can't do it in slow increments. So so I think it's that interesting balance. We want it to be perfect, but we also want it to be out there. So but it's seeking that constant improvement, I suppose. So.
Good. I mean, I'm the same. It's everyone is slightly tweaked and testing.
Yeah.
which adds a whole other layer of stress.
That's it. It'd be nice just to go, right, that's it, nailed, let's just rinse and repeat. Yeah. So, but that'd be far too straightforward, wouldn't it? So.
Nice one, Matt. Thank you for that. After we finished recording, we realised that we had actually both built straw bale houses for the same client in the same place. He built the main house, and then a few years later, I built a holiday home roundhouse with Heartwind there. So yeah, it's a very small natural building world. Okay, well, that is it for this episode. There is another episode of a couple more conversations available. That's episode 78. So you can head straight there. And just before you go, please can you do me a favour? If you're listening on Spotify or Apple, can you go over there and just give it a 5-star rating? That would be ace. Thank you. And if you're listening on Apple, could you spend 2 minutes and write a very quick review? It does make the world of difference to how many people get to hear the podcast. So that'd be very much appreciated. All right, until next time. Thank you. Bye.